Now let's take a look at continuity of a function. So the definition is very simple. You have a function, okay, and we say fx is continuous at some x value, which is say a, if the limit is equal to this value, fa. Okay, so that one is called continuous at a. So you can see that we must have a limit. So the limit must exist. And you also need to define this value is well defined at a, and these two must be equal in order for the function to be continuous. In simple words, a continuous function will look like that. A is here. All right, so it's just, there's nothing going on at this A. There's no open circle, there's no jump, no cut. Or you can just remember, if you follow the curve, right, in the neighborhood of A, if you can follow the curve, go all the way, from a value below A to a value above A without lifting your pencil, then this is called continuous, right? In that case, we can do that, because if you do this, you simply just follow the curve like that, right? You don't have to lift your pencil to cross A. Now, if you have to lift your pencil, for example, there's no way to go. Say you have at A, right? You have something which goes like that, and then it jump to another value, something like that. So if you want to go from below to above A, right, you have to make this jump, and you have to lift your pencil to go from the bottom one to the top one, right? So if that's the case, it's not continuous. So this is what we call discontinuous. Another case would be something like that, right? You have a function, you have an open circle. Open circle means you cannot be there, right? This is forbidden, so you cannot touch this point. That means, and if this is A, if you want to follow the curve from below to above, you can do this, right? Now, once you're at this point, once you are getting closer and closer to this point A, you cannot be there. So you have to, lift your pencil, make the cross, and then go to the other side, right? So you have to, there's no way it's just one smooth, continuous thing, right? So this one is also discontinuous. This is also discontinuous, okay, at only this A point. So just remember, if you can follow the curve, okay, from below to above, this point A, and if you can do that without lifting your pencil, and then this is continuous. Right? If you have to lift your pencil and put your pencil at another location, and that's not continuous. So that's the cases where you have function which is either continuous or not continuous. And for continuous functions, we also have some rules here. For example, if f is continuous and g is continuous, right, at some point A, then f plus g is continuous. F minus g is also continuous, and f times g is continuous, and f divided by g is also continuous if g a is not 0 at this point, right? Because we always require the denominator cannot be 0 if you do a quotient. So that's that. Now, this continuous property is very common. Most of the function you see, like the polynomial function or exponential function, trig functions, they are all continuous. All right, so that's some cases about continuity. Another case could be something like that. If you have x, fx, right? You have at a, the function goes all the way to infinity, and like that. All right. So that's called infinite discontinuity. So this is also discontinuous because you don't have a right. You cannot really do that, right? If you follow the curve, going this, you have to go all the way to infinity, and you cannot do that. So you cannot really follow the curve and go back down. So that's also not continuous. Okay. Now if you're given a graph about some functions, you should be able to specify, or should be able to see if the function is continuous at this point or another point, things like that. So that's continuity. In 2.6, we talk about horizontal asymptotes. So that's something like that. If you have limit, okay, of a function, now x doesn't go to a finite value. X goes to either infinity or negative infinity. So what does that mean? That means you have something like that. If x goes to positive infinity, that means x becomes bigger and bigger. So if your function looks like that, okay, your curve is getting closer and closer to some value. We call that L. Right? It's getting arbitrarily close. If that's the case, we just say the limit that x goes to infinity is equal to L. And this is horizontal asymptote, or limit at infinity. You can also do the other way, right? If x goes to negative infinity, that means x becomes more and more negative. So you are doing something like that. Now, if that's the case, then you can see that the limit is equal to, I call this m, right? Because if x becomes more and more negative, basically you follow this direction. And the value of the function is getting closer to this m value. And this is horizontal asymptote. All right? So one thing we see all the time is something like that. All right? This limit is equal to 0, because if x becomes super large, right, you have 1 over a huge number. So that's very close to 0. In fact, the limit is equal to 0. And you can also do other power, like 1 over x squared is equal to 0. Right? X cubed, limit x to infinity, 1 over x cubed is also 0, because when x is large, the denominator is super large. So the whole thing, 1 over that is equal to 0. So in fact, you have this 1 over x to the r is equal to 0 if r is positive. Could be r could be 1, could be a half, right? Even that one is equal to 0. Okay, because if x is large, square root of x is also large. So that's also 0. And that gives us the idea how to do the limit like this. If you have two, if you have a ratio or quotient of two polynomial functions. All right, so for example, you have x squared minus 3 over 3x squared plus 7x plus 1. All right, now if x becomes large, x squared is large, right? X is large. So what you do is you should divide by the highest power in the denominator for x. So in that case, we should divide it by x squared everywhere. That means you have x squared like that, right? 3x squared plus 7x plus 1 over x squared. Now you take the both numerator and denominator. So on the top, you have y minus 3 over x squared. On the bottom, you have 3 plus 7 over x plus 1 over x squared. And you can do the limit on each term, right? So you can do the limit of 1, which is 1. The limit of this is equal to 0. Limit of this is equal to 0 because x is a huge number, right? So 7 over x will be 0. 1 over x squared will be 0. So at the end of the day, you just have 1 over 3. So it's 1/3 for this limit.